All right, so I think this is recording. Let's take a look at these two problems. They're both radical equations. Our approach in both of these is to um, get the radical by itself, square each side of the equation, get our potential solution set, check for extraneous solutions, and then we'll have our final answer. And let's jump in and do number 8 here. Um, we have the term that contains the radical already by itself. So I'm going to square each side of the left-hand side and square the right-hand side. So exponents do not distribute. So x minus 4 times the quantity x minus 4 is x squared minus 8x plus 16. And on the right-hand side, if we take this and multiply the term and multiply it by itself, the 2 times 2 is 4. And the radicals, when you square it, the radical goes away. So this is a quadratic equation. We can get this in standard form. But first, let's use the distributive property. And on the right-hand side, write this as 4x minus 20. So now we want on the right-hand side for that to be 0. So we've got x squared. We're going to subtract 4x from each side. So instead of 8 here, it's minus 12x. We're going to add 20 to each side. So that'll be 36. And this factors to x minus 6 times x minus 6. So this gives us a possible solution of x equals 6. Now, we don't know yet if that's extraneous or not. We're going to have to check that in the original equation to see if the original equation is satisfied. We do know that it's a solution to this quadratic, but we also know that when we squared each side, that was a non-invertible operation, so that may have introduced extraneous solutions. So checking this, on the left-hand side I have 6 minus 4, and the question is will we get that same amount on the right-hand side? We have 2 times the quantity 6 minus 5. So on the left we have a 2, and on the right 6 minus 5 is 1. The principal square root of 1 is 1. 2 times 1 is 2, and we have that 2 equals 2. So yes, this does check, and there's my solution for problem number 8. Let's take a look at problem number 9. Now, the radical is not by itself. If I jump in and mistakenly square each side, the result of that, I'm still going to have a radical. So I have to be clever, and I have to get the radical by itself in order to, when I square it, for the radical to go away. So I need to take x away from each side and add 1 to each side. All right, so let's square each side to get rid of the radical. So on the left-hand side, we just have x squared plus 3. And on the right-hand side, we have x squared minus 2x plus 1. So if we subtract x squared from each side, we see that these terms cancel. If we subtract 1 from each side, 3 minus 1 is 2. And so x has to be negative 1 because negative 2 times negative 1 is positive 2. Now, we don't know if this is a solution yet, though. Let's plug it in and see. X we replace with negative 1, so instead of x minus 1, we've got negative 1 minus 1 plus the square root. You're going to have to square this negative 1, which is still positive 1, add 3 to it. Question is, are we going to get 0? So negative 1 minus 1 is a negative 2. And negative 1 squared is 1, and 1 plus 3 is 4, and the principal square root of 4 is 2. And yes, negative 2 plus positive 2 does equal 0, and x equals negative 1 is our solution. It is in the solution set. It's our only solution. to problem number 9. So I hope that helps. Ask questions as needed, and I will talk to you later. Bye.